Good morning. In today's session, we have to study about the boost converter. This is the type of switching voltage regulator. In yesterday's session, we have seen about the buck converter. What we are saying, if we are using the switch to get constant output voltage, or that voltage will be in increased amount or in decreased amount, or it will be inverted with respect to input voltage. At that time, we are saying that voltage regulator as a switching voltage regulator. So, if we will get the output voltage that will be less as compared to the input voltage. At that time, we are saying that voltage regulator as a buck converter, or we can say it is as a stepped out converter. So firstly, we will see one example for the buck converter. There is a question like design a buck converter for continuous inductor current with given specifications, where we will get output voltage that is nothing but 18 volt. R 10 ohm load resistance. It means what? This is the value for RL. The output voltage ripple less than 0.5%. The DC supply, it means what? The input voltage, 48 volt. They have given output, they have given input, so we can derive the value for the duty cycle. This is nothing but the ratio of output voltage with respect to input voltage, or we can say it is the ratio of input current to the output current. But यहाँ पे हमें output voltage और input voltage है, so we can derive that value. After that, they have given the switching frequency. It means what? F. And here we are supposed to specify a duty ratio that is nothing but output with respect to input. Just wait for what we are saying here. We are supposed to find the value of inductor and capacitor. In yesterday's session, we have seen some formulas. These will be useful to derive the value for inductor and current when we are having the value of output voltage, input voltage, when we are having the value for duty cycle, frequency, load current. At that time, we can derive inductor, capacitor. Also, we can derive the output voltage ripple, but already they have given here output voltage ripple. This formula will be needed. So here, what we are saying here, they have given us the minimum L. It means what? We are supposed to find that L minimum to ensure continuous conduction mode. At that time, we are having the formula for inductor, that is nothing but 1 minus dr upon 2m. All values we are having. D का हमने just derive किया है, R और F का उन्होंने दिया है. They have given here. So we can put this value, we will get the value for that inductor. After that, we are supposed to find the value for the capacitor. We are having the formula. They have given delta V0. They have given here, that is the 0.5%. So 0.5 upon 100, you can take 0.005. Remaining values we are having. D, we have calculated 0.375. So we can write here 1 minus 0.375 divided by 8 as it is. L, just we have derived. Then we are having delta V. We are having the output voltage. We are having the frequency value. So we can put these values, frequency ka square. What they have given here? 40. So 40 kilohertz, uska square. So you can take that as a 40,000 ka square. You will get the value like 100 microfarad if you solve this mathematical term. After that, they are saying we are supposed to find average value of IL minimum, IL max. We are having the formula here. IL max, IL minimum are 1 minus D upon 2F. We can calculate. So here, when we are calculating the value for IL, at that time we can take that value is output voltage upon that resistor. So you will get 18 upon 10, that will be nothing but 1.8 ampere. Now we are supposed to find IL max, IL minimum. So here, firstly we can find delta IL. It means what? We will get the value for IL. So we are having the delta IL, that is nothing but VI minus VO. VI 40. VI we are having here value. VO we are having their value. So we can put these values. We can put the value for L. We can put the value for D duty cycle. We are having the frequency value, so T equal to 1 by M. We can put. You will get the value for delta IL, that is nothing but 2.88 ampere. Now, when we will get the value for delta IL, we will get the value for inductor current, LI, IL, it means. At that time, you will get the value for max current and the minimum current, because we are having the formula max current will be inductor current plus the change in inductor current with respect to 2. It means what? The half of that current. And we are taking the summation of this. So you will get the value. So we can take IL plus delta IL by 2, and minimum will be IL minus delta IL by 2. So you will get this value. After that, in D, the peak voltage rating. It means what? We are supposed to find VP. At that time, we are supposed to consider ideal components because they have given it. So here, the maximum voltage they have given 48 volt. VI 48. Voltage rating for switch and the diode, that will be greater than input voltage, so we can take that is the greater than 48. So here the inductor voltage when switch is open, you will get VL equal to minus VO, and we are having VO 18, so you can take minus 18. Now if our switch is open, we are having the equation for VL, VI minus VO, because when we have seen this diagram, at that time what we are saying, if switch is open, at that time current will go only to the inductor and load. So you can take here load means VI, that is nothing but that will some go to the inductor and that will go to the load resistor. So VI to VL plus VO you can write, so you can reconvert that equation in the form of VI minus VO. Okay, so here now we are having all these values. They are saying voltage rating for the inductor will be greater than 30 volt. So here we are having the output voltage. So we can say the voltage rating for the capacitor will be greater than that output voltage. That is nothing but the 18 volt. So here we can derive the maximum voltage level. Now we can see about the boost converter. What we are saying, if we are using the converter, we are using the DC to DC voltage regulator, and we will get the output voltage that will be in the increased amount with respect to the we will get the output voltage that will be in increased amount with respect to input voltage. At that time we are saying that voltage regulator as a boost converter. So here when the switch, if we are using any transistor, that is MOSFET, that is JFET, that is transistor, you can use here any switch. What we are saying, when we are supposed to study about the switching voltage regulator, at that time we are using the switch which will allow to get the DC voltage at the output. That will be in increase, that will be in decrease, or that will be in the inverting proportion with respect to the input voltage. So here, if you see in the buck converter, what we were doing here, if you see here at the switch, here we were using diode, here we were using the inductor, and here we were using the capacitor. So here we are changing the places for the switch and inductor and the diode. in the boost converter, because here we are supposed to increase the voltage at the output. So here this is the basic diagram for the, we can say as a step up voltage regulator, or we can say it will be as the boost converter. So here when our switch, that will be if we are using the MOSFET. So we can say when the MOSFET switch is conducting, it means what? That switch is in closed condition. That time, if you are taking that as a switch is on, it means what? The switch is closed. At that time, current I in. When we will give the power supply, it means what? DC input voltage. At that time, input current will flow through the inductor. यहाँ से क्या होगा? इंडक्टर में से करंट फ्लो होगा, which will store the energy, and we are aware about the properties of inductor. Inductor will store the energy in the form of magnetic field. जैसे कैपेसिटर चार्जेस की फॉर्म में एनर्जी स्टोर करता है, वैसे इंडक्टर क्या बोलते हैं? मैग्नेटिक फील्ड के फॉर्म में. So when we will give the power supply, at that time it will store the energy that will be in the form of magnetic field. So here, but when we are making the switch off, जैसे ही तुम switch को off करोगे, at that time we can say here MOSFET switch is off. The sudden drop will occurs in the current, which will causes L1 to produce the back EMF. And we are aware about the back EMF. Back EMF, it means what? The EMF which will work in the opposite direction with respect to input voltage. It means what? What we are saying here, when we are giving the input voltage. But how we are giving? When we are making the switch off. When we are making this switch off, it means what? We can say when the MOSFET is rapidly turned off, there will be the sudden drop in the current, which will causes to produce the back EMF, which will work in the opposite polarity with respect to the voltage across the inductor L1. So this result will be in the two voltages, that will be in the supply input voltage, and that will be, there will be the back EMF which will produces across the inductor, because inductor is having the property, if we are using the inductor at that time, when it will be in the charging phase, when we will give the power supply, at that time current will flow and it will allow to store the energy in the form of magnetic field. So here when we are making the switch off, at that time that will produces the back EMF and it will work in the opposite direction with respect to the input voltage. So here we can see this higher voltage, that is nothing but we are having the voltage across inductor, that is we are saying back EMF. You can say E or you can say EB, it means what? E suffix B, matlab back EMF. Or we can say VL, this is also the same meaning. We are saying back EMF as the voltage across inductor. So here, this higher voltage forward biases diode, because when we are giving input voltage and when that switch is becoming closed, at that time it will produces the back EMF. Just because of this reason, input voltage will increases, and as that input voltage and that back EMF will biases diode D1 in the forward biasing condition. So that's why there will be current will flow through diode D1, which will charges C1. क्या होगा? If you see, when it will works, when that diode will go to the on condition, because here we are making the switch off, at that time here there will be higher amount of current because of this input and because of this back EMF. तो ये डायोड क्या हो रहा है? फॉरवर्ड बायस में आ रहा है. As this diode will come in the forward bias, it will allow capacitor to charges. So the resulting current through D1 will charges up to C1 to Vin plus VL minus the small forward drop voltage that will be across the diode and which will given to the load. We can see here we are having the load at the output, so it will supply voltage to the load also. So here if you see, these are the circuit diagrams. This is the circuit diagram for the boost converter when we are giving the input voltage and when we are making switch on. This is the diagram. And if we are making the switch off, at that time you can draw this diagram and you can explain like this. So here we can say the circuit will show the circuit which will work during the MOSFET will be on period after the initial startup, because here when we are giving the power supply, each time MOSFET will conduct, and as MOSFET will conduct the cathode given, the cathode of diode is more positive than its anode due to change on the capacitor value. So here D1 is turned off, so output voltage is isolated from the input voltage, and however the load continues to the supplied with input and the output voltage. So although we can say the charge C1 drains away through the load during this period. So now we can see the formulas which we will require to calculate the values of the parameters which we are using in the boost converter. We are using their inductor, we are using their capacitors. So we are supposed to find the value for L and C, like we have solved in the boost buck converter like this. But what is the difference here? Here we are using the inductor, after that we are using the switch, after that diode, and here is a capacitor. So these are the equations you will be needed to solve some numericals which will be on the boost converter, that will be in the continuous conduction mode or it will be in the discontinuous conduction mode. If you are supposed to find the D, you can solve D equal to VO upon V minus. If you are solving VO minus VI for continuous conduction mode, at that time you will get, वहां पे D का value directly तुम्हें मिल रहा था VO upon VI, but here if you see we will get the boost converter duty cycle value that will be equal to 1 minus VI upon VO, or you can say VO minus VI upon VO. You will get the value for the duty cycle. You are having the equations for the ripple inductor current, ripple capacitor voltage. You are having the values for the discontinuous mode also. For the value for inductor, critical capacitor, and you are having the values for the discontinuous for duty cycle also. You can calculate current to current ratio, or you can calculate voltage ratio, that will be VO upon VI. You can calculate that like 1 plus VI d square T upon 2LIO. So here we can see one example. So you will get how to solve the numericals. You guys have given the test for the electrical circuit. If you are not given, then you can give today. Okay. After that, I will make that link disable. Okay. So here we are having the question like a boost regulator has input voltage VI equal to 5 volt, the average output voltage 15 volt, average load current 0.5 ampere, switching frequency 25 kilohertz. We are having L value 150 micro Henry. We are giving the unit for inductor as a Henry. We are having the value for capacitor, that is 220 microfarad. We are supposed to find the value for duty cycle. So here we can take output voltage equal to input voltage upon 1 minus D. So here we can take 15 equal to 5 upon 1 minus D. So you will get the value for D. If you reconvert that equations for D, you will get the value like 1 minus VI upon VO. So you will get the value like 2 by 3. You can calculate in the percent form. That will be 66.67%. Now you are supposed to find the ripple current of the inductor. It means for delta I. So we are having the value input voltage into output minus input voltage upon F, that is nothing but frequency, into L, that is nothing but 150 into 10 raised to minus 6 into we are having VO. If you will put these values, you will get the value for delta I, that is nothing but 0.89 ampere. So you guys are supposed to understand these equations only. If you will get these equations, you can solve any values because all will get from these equations only. So here again you are supposed to find the value for the peak to peak current of इंडक्टर मीन्स आई मैक्स आई मिनिमम आई मैक्स लाइक जैसे अभी हमने पिक बक कन्वर्टर में सॉल्व किया था आई आई प्लस डेल्टा आई अपॉन टू and I minimum will be I input current minus delta I by 2. Delta I just we have derived. Input current, if you see, we can derive because we are having the formula. So we can derive that will be like 0.5 upon 1 minus D. 1 minus D, 1 minus D. D का value क्या है हमारे पास? 0.667. So you can put the values, you will get the value for the IA. After that, you are supposed to find the ripple voltage of the filter capacitors. That is nothing but delta VC. So you can calculate delta VC like this. Again, you are supposed to find the critical value for inductor and the capacitor. So for that, you will be required the value for resistance, but they have not given. So you can calculate. We are having the value for output voltage. We are having the value for output current because they have given here output current is nothing but 0.5 ampere. So you can take output voltage, output current, you will get the value for the load resistance. After that, we can use our formula for the LC and the CC. You will get the answer. So here, another one example, we can see if the switching square wave has a period of 10 microseconds. The input voltage is 9 volt and the on is half the periodic time. That is 5 microsecond. It means time they have given. Then output voltage will be. We can calculate output voltage equal to. They have given here input voltage. So we can write VI upon 1 minus what they have given here. The on is off of the periodic time. So you can take that will be half of the periodic time. You can take that as a 0.5. If you calculate, you will get that value as a 18. So because here we can say the output voltage is dependent on the duty cycle, it is more important that this is accurately controlled. For example, we can calculate duty cycle which will be increased from 0.5 to 0.99% the output voltage produced will be. So again we can take V out equal to 9 upon 0.5 से तो कहाँ तक ले सकते हो 0.99. You will get this value. Before this level of output voltage was reached, however, there would be, of course, be some serious damages, and there will be if some damages caused at that time, we can say unless that circuit is specifically designed for very high voltages, the change in duty cycle are kept much lower that indicated in this example. So here again, if we are having the another example like step up converter, it means what? Yes, it will be the boost converter. Step up matlab kya? Boost converter. So they can give a step up DC to DC converter is to be analyzed input voltage 14 volt, output voltage 42, inductor 10 millihenry, resistor 1 ohm, Fs they have given. So we can calculate D equal to 1 minus Vi, V upon V out. You will get Vi कितना दिया है 40, V out कितना दिया है 42. If you put these values, you will get the value for duty cycle, that is nothing but 0.67. Or if you are writing in the percent, you can write 67%. Now you are supposed to find the inductor voltage. So here we are aware about the equations for frequency they have given here. Fs they have given. So you can convert that into a time t equal to 1 upon Fs. So 1 upon 10 kilohertz, you will get 100 microseconds. So here we are saying our duty cycle is 67%. We are saying t equal to 100 microseconds. So we will get t on will be 67 microseconds, and uska half you will get t off, that will be 33 microseconds. And we can plot this inductor graph like Vi upon यहाँ पे on here Vi के y axis पे on negative side we can take Vi minus Vo. So here if we are having example like given buck converter design with, this is the buck converter what they have given a buck converter design with frequency 200 kilohertz. It means what, they have given time also, they have given diode voltage also, its minimum voltage, they have given its current minimum, they have given its nominal current, they have given duty cycle. So here we are supposed to find VO. If Vi equal to 10 volt, duty cycle दिया है, output दिया है, we are having the formula for the duty cycle. So here I'll make that screen. Here you are supposed to find the output. We are having the formula VO equal to Vi upon 1 minus D. You can put value, you will get the output voltage. Again, you are supposed to find the value for the inductor. We are having the formula VO minus V in plus VD into 1 minus D upon minimum I load into F. If you put these values, 20 minus 10 plus 0.7 into 1 minus D is nothing but 0.5 upon I load into F. I load we are having here value as a 0.5 and F they have given as a 200 kilohertz. So you can write 200 into 10 raised to 3 or kilohertz. You will get the value for inductor, that will be 54 microhenry. Now you are supposed to find the value for the output voltage if Vi equal to 10 volt in the discontinuous mode. At that time, we are having the equations for the duty cycle that will be in the form of inductor. So you can take in the discontinuous mode का gain कितना है, voltage का ratio VO upon Vi equal to, we are having for discontinuous mode 1 plus Vi d square t upon L 2 L into 2 into IO. So we can put these values. If you are putting these values for if you put all these values 1 plus Vi, we are having the input voltage, that is nothing but here they have given 10 volt. So here we can take discontinuous के लिए वहाँ पे they have given we are 10 volt, 10 into duty cycle का square, we are having duty cycle they have given 50% 0.5 का square into t they have given here 5 microseconds, you can take 5 microseconds upon 2L I0, L we have just derived 2 into 54 microfarad. I0 they have given there, I0 is nothing but 10 ampere. So you can take, you will get the value for VO. That is nothing but 10 minus 1 to hold. Now, this is also the same example. They have given all these values. Only you are supposed to design a boost converter with V input, V output, IO, FS 48. You can solve. This will be the homework for you guys. You can solve at your home and you can cross check your answer with here. After that, when they have given design, at that time, after solving this and after getting the remaining values which they have asked, you can draw the diagram and you can put their values. And if you want, you can draw this cycle also. These are nothing but the timing diagram. If they have given design a boost converter, it means you are supposed to draw the circuit diagram and the wave diagram for this. But if this question is for 3 marks, and if they are giving here, you are supposed to design. At that means you are supposed to find the value for inductor, you are supposed to find that value for the input voltage, but they have given here. Output they have given. If they have given 2 to 3 terms, which are not they have given and you are supposed to find, at that time if you are drawing this diagram only, it will be sufficient. But if the calculations is very easy and only you are supposed to find any one value, at that time you can draw this timing or wave diagram, the waveforms for this boost converter. Okay, so here what we are saying, there are the power losses in the buck converter. These are nothing but there are two types, the AC switching losses and also there is a DC conduction losses. So here we can see about the DC conduction losses. The conduction losses of the buck converter result from the voltage drop, which is because of the transistor, diode and the inductor. Because when they will conduct the current, at that time there will be the conduction losses in the buck converter. And here we are using the MOSFET for the power transistor. So here the conduction loss of MOSFET, we are having the formula like IO square into RD into D. DS is nothing but drain and source. Drain and source on condition, the resistance. So here we can say it is the on resistance of the MOSFET Q1. So here the conduction power loss of the diode, the conduction power loss of the inductor, we are having the equation. So we can say as we are using the transistor or the diode, or we are using here inductor also. So here we can say there will be the conduction losses in the buck converter. Again we are saying there are the power losses in the buck converter. So therefore conduction losses of the buck converter is approximately the conduction loss of transistor plus the conduction loss of inductor plus the conduction loss of the, we are saying here we are using the diode, here we are using the transistor and here we are using the inductor. So that loss will be because of these three. So here when we are considering the conduction loss, at that time our efficiency will become, this is nothing but buck converter ka efficiency nita, that will be the output power upon output power plus the conduction losses power, P conduction loss. So here if we are having any question on to determine the value for the conduction loss, at that time we are supposed to use these equations. You will get the values. So here we can see one example. After that we conclude our session. So for 12-volt input buck converter, there is 3.3 volt upon 10A max output back supply. Use 27.5% duty cycle. D का value परसेंट में दिया है, so you can take 0.275 because 27.5 upon 100 provides a 3.3 volt output voltage. You can take VO equal to 3.30. So you will get V out equal to V in into D. This is the buck converter. Huh? Don't confuse. In boost में equation क्या था? D equal to 1 minus V in upon VO था. But in buck converter, we are having the formula for D, that is VO upon VE. So you can write VO upon VIN equal to D. So you can reconvert and you can write for the V out. So you will write V out equal to VIN into D. You will get the values. Again, they are giving here DS resistance, means drain source resistance for the on conditions. They have given. Diode forward voltage VD they have given, which will we require. Diode inductor resistance They have given. We can put these values, you will get the conduction loss. Now we are having the output voltage, output current, so we can derive output power 3.3 upon 10. If you solve these P output upon P output plus P conduction losses जो यहाँ पे आया है, they have given 3.3 upon 10A. You can write 3.3 upon 10A. That will be, if you are writing like this, you will get value for the neta conduction, that is 88.96%. So here we are saying there are switching losses also in the buck converter. These are nothing but the MOSFET switching losses, inductor core losses. There are other AC related losses. MOSFET switching losses, because here we are using the transistor, and a real transistor will require time, that will be to turn on or the turn off. That we can say there is the switching loss. So there are, if you see, there are voltage and current overlaps during the turn on and the turn off transients, which generates their AC switching losses. Again, there are inductor core losses. A real inductor also has AC loss, that is function of switching frequency. Other AC related losses, like there is AC losses which will include gate driver loss, the daytime body diode conduction loss. So we can say there are switching losses, there are inductor losses, there are the losses because of power conductions also, because of transistor, because of triode, and because of inductor also. So here we can conclude our today's session. Now I'm taking your attendance. If anyone is facing any issue regarding numericals or regarding theory, you can ask the question. Okay, thank you. You guys can leave now. You all are supposed to join class for electrical circuit on the 9:45. Okay, thank you.